Let's continue from question 3. In my previous video, I've solved questions 1 and 2. So we're going to continue from question 3 today. Question 3 is a rational function, so let's go. So 3, I have limit of 3x squared plus 12x minus 6 all over 2x minus 1 as x tends to 3. Now, anytime you are solving a rational function, the first thing you do is to check if the denominator is going to give you 0 when you substitute in the value of x as given here. So I'm going to verify if I put 3 in place of x at the denominator, will it be 0? No. If no, just go ahead and do your usual substitution and evaluate your answer. That will be all. If otherwise, we are going to do something which I will tell you later. Probably question 4 will give us that opportunity. But for this, let's substitute in the value of x as 3. So we'll have 3 into 3 squared, since x is 3, plus 12 into 3 minus 6 all over 2 into 3 minus 1. Now, anytime you are evaluating, I want you to take note. As you are evaluating, you take away the limit sign. As you can see, you can't find limit here again. At first it's limit, but immediately I'm substituting in for the value of x, I remove the limit. So this is going to be 3 times 9 plus 12 times 3 is 36. Minus 6 over 6 minus 1. Now this is going to be, let me come down, this is going to be 27. 3 times 9 is 27 plus 30, taking away 6 from 36 all over 5. So this will give me 57 over 5. Now it's as simple as this. Please, at every point you are lost, just pause the video and check them critically step by step, and you can replay as many times as possible until you've gotten the secret. Now let's quickly go and solve question 4. So question 4 says limit of x squared minus 25 all over x plus 5 as x tends to minus 5. Now, as usual, I told you verify the value of x as given here. Let's see if we put it here, will it give us 0? The answer is yes. So if yes, we will not proceed to substitute. We will do 2 things I'm going to tell you here. The first is to factorize. Do what they call factorization. The essence of this factorization is to see how you can get rid of this denominator, because as long as it exists, we will not be able to substitute in minus 5. So if we can get rid of x plus 5, that is the denominator, we'll be able to succeed. So first thing you have to watch out is to see if you can factorize the expression. Then the second thing you do, if not factorization, is to take the derivative of both the numerator separately and the denominator separately. Now, over time, this method is deficient because not all expressions are factorizable, and in the event that they are factorizable, it's possible that you might not be able to cancel out this denominator. So because of that reason, this is a bit deficient to solving all the questions in that limit. But derivative is very potent. Okay, so let's factorize. This case factorization will work. we are going to do factorization. So that will be limit as x tends to minus 5, x plus 5, x minus 5, all over x plus 5. Wondering what happened? Now this is it. For x square minus 25 can be written as x square minus 5 square. This is what we call difference of two square. So if you have a case like this, you open two brackets. One will be x minus 5, one will be x plus 5. So that is how I got the numerator. So after doing this, you discover that what we wanted will happen, and that is we'll be able to cancel off the denominator. So this expression becomes limit of x minus 5 as x tends to minus 5. So direct substitution, you have minus 5 minus 5, that will give you minus 10. That is it. So watch it over and over. Okay, now let's try the differentiation, taking the derivative. I will show you right away. Now if I have to take the derivative of the numerator and denominator, this becomes limit of 2x as x tends to minus 5. Yeah, I'm pretty well you are wondering what happened. Now for differentiation, assuming y is a function of x raised to power n, the derivative, that is dy dx, this is a formulation, it's nx n minus 1. This simply means for any x, the power of x will be brought down as coefficient, then the remaining power, you will just subtract 1 from it as suggested. For instance, if you have x raised to power 2, 2 will be brought down, then subtract 1 from 2 will be 1, and when you have the power as 1, there is no need writing it. So that is how I got to here for x squared. Then what happened to 25 and 5? In differentiation, if there is no x attached, the derivative is 0. And for x, the derivative of x is 1, following the formula. So let's see what answer that we're going to get, if it's going to give us the same thing with our previous answer, that is minus 10. I guess at the sight of it, you would know that it's the same. Now, so this is just going to be minus, 2 times minus 5. I'm substituting direct the value of 5. This will give you a minus 10. The same, and probably even easier. Thank you, and God bless you. Please share the video.